Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are talking about quadratic optimization. It is spelled using the British type spelling. In America, that would be a Z, but no matter. Quadratic optimization. Here we go. We will come back to Angels and Airwaves, the adventure at the end of the show here. So, if you graph a parabola, yes, which is the graph of a quadratic, there will be a maximum if we have a parabola that opens downward. Yes, just like it's shown there. This isn't a parabola, but it's close. You can see where we would have a maximum there. And this is actually what a parabola would look like if it was rotated in 3 dimensions. And it too would have a maximum. And of course, if we had a parabola that opens up, we would have a minimum, okay? And all of those would occur at the vertex. So that's what we have here. We already know that the axis of symmetry is negative b over 2a, so we can always find the x-coordinate of the maximum or the minimum, and then once we find that, we can substitute that back into the original function to find the y value, which is generally the value we are looking for. That is, y is the value of the function. We've talked about that in class many times. So, just a straightforward generic thing. Find the maximum or minimum value of the following quadratic functions and the corresponding value of x. So we have to find the value, so that means the value is the y value. So to find the y value, we need to find the corresponding value of x where it is a max. Okay, so this is a parabola that opens upwards because of the positive coefficient, the positive leading coefficient. So it's going to be a minimum. Okay, so I start by using x equals negative b over 2a, which gives me the axis of symmetry as well as the x-coordinate of the vertex. So I'll just go ahead and put that there. So that in this case, it's going to be negative 1 over 2 times 1, which is negative 1/2. So to find the y value, I say negative 1/2 squared, substituting it into the original function, minus 1/2 minus 3. And without doing the work, I'm going to tell you that that is equal to negative 3 1/4, or it could have been negative 13/4. Doesn't matter which. So we have a minimum value. There is a minimum value. This is very important, the difference between the value, the actual minimum value, and where it occurs. Minimum value of negative 3 1/4 occurring when x equals negative 1/2. I cannot stress the importance of this enough. Again, the minimum occurs when x equals negative 1/2, and the minimum value is negative 3 1/4. Again, the independent variable, negative 1/2, and the dependent variable, negative 3 1/4, your x and your y. Y depends on the x value and the x-coordinate, and the y-coordinate gives us the value of the function. Always very important to understand that. Let's try it for b over here. It's opening downward because of the negative leading coefficient. So that means we'll have a max. Yes. So we're going to say x equals negative b, and b in this case is 3, over 2 times a. So that's 2 times negative 2. So that's going to be equal to 3 over 4. So y is going to equal 3 plus 3 times 3 over 4 minus 2 times 3 over 4, the quantity squared. That would be 9/16. And I will tell you without wasting time that that is equal to 4 1/8 or 33 over 8. Either one is okay. Of course, it depends on the context too. So we say that the minimum and I won't spell out minimum. Oh no, it's a max because it opens upward. The max value is 33/8 occurring, happening at x equal to 3/4. Okay. And we'll give you one application example here, and that'll be it. You'll be on your way. A gardener has 40 meters of fencing to enclose a rectangular garden plot where one side is an existing brick wall. So here's the brick wall. Suppose the two new equal sides are x meters long. So this is x, and this is x as well. Show that the area enclosed is given by this formula. Okay, so A, the area is equal to length times width, okay, or width times length, because we already know the width. So it's x, right? Here's the width. So we have to have an expression in terms of x for this length. Well, if all the way around is 40, right? All the way around, the length of the fence is 40. And so I've got 40, is it feet? Meters, 40 meters of fence. And here I use x meters. So now I have 40 minus x meters. And here I use x meters. So I have to subtract another x meters. So that's equal to 40 minus 2x. And that is how much is left after you take these off, which is what we would use for the length. So this length right here is 40 minus 2x. So length times width, or width times length, is going to be x times 40 minus 2x. Okay. So there we go. X times 4, we did it, and that's its area, so it's square meters, so we did that. B, find the dimensions of the garden of maximum area. You can see that if we distributed this x, we would have a negative 2x squared, so the parabola would indeed open downwards, right? And so we would have this axis of symmetry. And I'm not quite sure exactly what the parabola looks like, but let's just say that here's the coordinate axes, right? And we know that the axis of symmetry, or the x-intercepts, are the same distance from the axis of symmetry. And if I know those, I can easily find the x-coordinate. Now, you can always distribute this through and use our handy-dandy formula, x equals negative b over 2a. But if you want to be efficient, we can quickly find the zeros here by using ZPP. Yeah, you know me. If I set this equal to 0, x equals 0, 40 minus 2x equals 0, and then for this equation, x equals 20, right? So this would be 0, this would be 20, which means this would be 10, right? Halfway between, which means the x-coordinate of the vertex is 10. And that's a little bit quicker, I think, or just another way to go than using x equals negative b over 2a. So that means that x equals 10, okay, for this vertex, and I can find y, or the area actually, the y-coordinate, by substituting in 10 for x. So that would be 10 times 40 minus 2 times 10. So that's 10 times 40 minus 20, or 10 times 20, which is 200 square meters. So the maximum area is 200 square meters, okay, when x is equal to 10, okay? In other words, when the width of the fence is equal to 10. So we would have 10 meters of fence here, 10 meters of fence here, and 20 meters of fence here. 40 minus 2 times 10 is 20. Now, I didn't have to calculate the area. I just wanted to show that to you because the question is, find the dimensions. So the dimensions are 10 meters by 20 meters. And so we've taken care of that. So you can see the power of modeling something with quadratics, because you can easily find a maximum or a minimum. Outstanding. I hope you enjoyed that. I know that I did. Let's check back in with Angels and Airwaves, and that will be the end of our time together. I hope you enjoyed it, because I am out.